And hello everyone, welcome to your very first Love2D project tutorial. So in this tutorial we'll be creating a save the ball game. Don't know what that game is? Just wait until the next part and I will give you a slight preview into what we'll be doing. Now, what do you need to know in order to follow along with this tutorial? You, for one, definitely need to know Lua. Lucky for you, I do have an entire Lua crash course available for those with the heart to follow along. So right there, full Lua programming crash course. An almost 4-hour long video describing everything you'll need to know in order to code Lua. Why do you need to know Lua, you might ask? Well, Love2D requires Lua in order to work. You code Lua, but use Love2D to make the game. If you know Lua, then great. If you don't know Lua, I recommend you learn it, but it is fairly simple to understand. So if you do understand concepts such as variables, if statements, OOP, then you can probably follow along without a problem. Next up is you'll need to know a little bit about Love2D. Also lucky for you, I have a 5-part series that will teach you the basics you'll need to know to be able to follow along. Whilst you don't have to follow these because I'll be explaining most of the things anyways, I do recommend you do. After that, you can start with the tutorial. This is a full crash course, but if you prefer watching video by video instead of an entire one video, you can also follow along with the video system here. So this creating our first game in Love2D, it's part of the playlist, but this entire video is just basically all of these combined into one big video. So it's just the personal preference you may have. Now, if you think you are ready, you know a little bit about Love2D and you know Lua, then you can jump right in. Even if you don't know anything about Love2D, you could probably still jump in. Alright, so let's get to the video. You probably want to see what game we are going to build. So let me just start up everything here and then boom. Now here we go. So this game is called Save the Ball. It's one of the very first games I made when I tried to create a game. So we have things like the FPS counter, which is optional. We have buttons and yeah. Now if we click on play game, we basically get this. We get a little counter here that counts how many points we have. This is based on seconds. So every second will give you a counter or a point. And then if you have enough points, then the next level will start where there appears another ball. Now these balls will get faster and faster with every level you make. For an example, in this case, the first level is 15. And then the second level I believe is 30, yes. And there's another level at 40 I believe, and one at 60, and it just goes on. But it's a very basic game, but it teaches you things like collision detection, how DT works, how to get the FPS, how to draw shapes, all of these things in Love2D. And then you also have your game over screen with your score, and you can say something like replay if you want, and yeah. So that's the basics of the game. Now if you do ever fall behind when trying to play this game, you can always just go to, whoa, my bad. You can always just go to GitHub, and this link will be in the description. If it's not, just send a comment my way and I will remember to put it here. Now in this repository here, YouTube projects on Weebnetsu, you can go here to Lua, and inside of it you'll see a folder called Save the Ball. And in here, you'll have multiple parts. We are on part 1. So everything we're going to do is going to be right here. So if you fall behind or you want to maybe go check, you can come here. And part 5 would be the end result. Okay, cool. So let me just move this back to its original screen. Now here I have an empty folder. I'm going to create a new folder and call it Save the ball. You can add spaces and whatnot, but I'm going to keep it spaceless. And then in here, I'm going to create a new document or a new file and call it main.lua. Now, what do you need to know before we start with this tutorial? You need to know Love2D. I have a whole course on it with like 5 parts or something that you can watch. If you have not seen those tutorials yet, I do recommend you do, because they are going to be very useful. You don't have to see them, we are going to cover a lot of things from the start, but I do recommend you do, because it will just make things so much easier if you do. And you also need Love2D installed, of course. Now I'm going to open up VS Code in here, but you can open up whatever you want to. I just prefer coding in VS Code. So here's VS Code. I'm going to close this. And here you see there's my main.lua file I created. Cool. Now, let's start by first importing love. So I'm going to say local love is equal to require and love. Now we can create our 3 functions we need. So function love.load. Now this one will be love.update. And this one will be love.draw. Cool. So as we know, this will load everything we need into the game. This will update the game. And this will draw everything to the screen. Now, we can save this, and we can also open up our terminal, which I'm going to move to the right. And now here we can say love dot. So it does nothing. Love2D here does absolutely nothing. So what I'm going to do, you do not have to do this, but I'm going to do this. If we can just, there we go. I'm going to create a new file, call it conf.lua. You do not need to create this configuration file. I, however, am going to create it because I would like my window to pop up on the second screen. But you do not have to do this because you might not have a second screen. So t.window.display, and we can make that equal to 2. This should open it up on this window. Now we can just run love dot again, and there we go. Cool. Now we can go back here. I'm going to close that conf file because I don't need it open anymore. And yeah. So first, I would like to set the title of the window. So love.window.set title, and we can set it to save the ball. Now you could have also put this inside of that conf.lua file. If you saw my tutorial on it, you do know how to put it in there. Although I want to show you the alternative methods of doing these things as well. So I'm going to do it on the onload of this Love2D game. But if you want to, you can do it here as well. Because you can do this Windows display thing, you can also do it in here. You can do the Windows resizing in here, you can do everything you want in here. First thing I want to do is I want us to be able to see the cursor. Because if you might have noticed, or as you may have noticed, if I were to just move this back here, our cursor is a little white dot. That's our mouse. I want to code this into the game right now. So let's do that. Let's code it in. So first thing we'll need is we'll need to get the player location. And that's going to be that little circle. So local player is going to be equal to this. And you could also put this inside of this load. It's optional. Then we need 3 things. We need the radius. And I'm going to make that equal to 20. We need an X position, and we're going to make that equal to 30. And we need a Y position and make that equal to 30. You could make this equal to 0 as well. It doesn't matter. I just like doing 30 because why not? Cool. Now we need to basically always update that position. So player.x and player.y is equal to the mouse.get position. So this right here returns two values. It returns an X and a Y position value. So we're storing the first value we get into this player.x, which is this, and the second value we get in the player.y, which is this. And we're doing it on every update, because every time the player moves the cursor, an update will occur. Now you may also notice, if I move around, things might look a little bit laggy, but that's just because I record on 15 frames per second, because that's just what I'm used to and that's what I edit in. So things may look a bit laggy, but on your end it should not be looking laggy. You should be getting about 30 to 60 frames a second. Alright. Now here with the draw, we want to basically draw the circle. So I'm going to say love.graphics.circle, and I'm going to go fill method player.x, player.y, and also player.radius. This will draw a circle where the player's x and y meets up and give it the radius that we specified up here. Now if we were to run this, we'll get a massive circle. Now this is the in-game circle, because we will have two states that we're going to be using right now. And those two states will determine the size of the player. So I'm going to create a local game, and it's going to be a table with state. Now we have a menu, and we're going to make it equal to true. Now this will be the states we have. So for example, we have a menu state. If it's a menu state, it's going to show the menu. If it's the paused state, it's going to show a paused menu. Now here I'm going to make that paused. I'm going to make that running. And I'm going to make this ended. Now currently, we want all of these to be false. And just this one to be true. That's for the menu state. Now down here, we want to specify when should it do what size. So I'm going to go if game.state, and we declared state up here, and then in square brackets and in quotation marks, I'm going to say if it's the menu state. So like that, and you'll notice right here. So if it's the menu state, then we want to basically do this, and we just want to divide this by 2. So if it's the menu state, then it should be the normal circle size, but just divided by 2. I'm going to create another if statement, but this one will contain a not menu. And there's a reason I don't make this an if-else statement, and you'll see in the future tutorials. So here I'm just going to remove that divided by 2. Now if we were to run the game, we'll see this, a much smaller circle. That's because we're in the menu state, so the circle is half its original size. Now if I were to change the menu to false, and then the running to true, and my bad, these two should be running, not menu. And now that we have that, we can actually just move that, so divide it by 2, and we can just move it to the bottom one. So now the first one is if the game is in its running state, meaning if the game is being played, give us the full circle. Otherwise, in any other state, half the size of that circle. Now if we run it, we get the full circle because it's in a running state. Any other state we switch to, no matter what the state, if we make this false and we make the state of paused to true, then we'll get the smaller version, as you can see here. So any other state will give us the smaller version, but running will give us the big version. Cool, so I'm going to change this back to menu state. Now we need to hide the cursor, because as you can see, the cursor is still there. We don't really want the player to see the cursor because it breaks the immersion a little bit. So to get rid of the cursor, what you can do is here in the load, we can say love.mouse.setVisible, and we can make this equal to false. This will make the mouse
invisible. So now, if you run it, there's no longer a mouse. I can still move around, but the mouse itself is gone. Now, one last thing I do want to implement is the FPS counter, because let's say you're getting very bad FPS. You might have coded something wrong or something like that, because the FPS should usually stay at around 60 FPS, maybe falling to 30, but usually it should be 60 FPS, and we need a way to see that. So here at the top, because we don't want the FPS to block anything, so it should be at the top, so it always, if there's something above it, the FPS doesn't go over it. Anyways, we can say love.graphics.printf, and here we can just say FPS colon, and then dot dot, is to concatenate the string, love.timer.get FPS, and that should be timer, not time. And there we go. Now if we run it, we actually get an error, and I believe we get this error because we should specify our font. So love.graphics.new font, and I'm going to specify 16. And let's specify an X and Y location as well. So let's go 10, 10. So now we have a font size of 16 and its X and Y position is 10 and 10. Now if we run it, we still get an error. And we just also need to specify where it stretches to. So love.graphics.width should work perfectly fine. And this should be get width. As simple as that. Now let's hope for the best. There we go, we get a little FPS. As you can see, it's around 60 FPS, and that's where it's good. Okay, cool. Now just because I have a little screen space, I'm going to just split this up into multiple lines. Like that, okay. So first we display the FPS. Then we set the font size. Then here is the X position, which we can keep 10. Here is the Y position, which I would actually like to go love.graphics.getHeight minus 10. And this will put it at the bottom of the screen, which is what I want. I want the FPS to be at the bottom of the screen just because it's less distracting. Let's make that 30 just to make it a bit bigger or a bit higher. And in this basically sets how far it should go before wrapping the text. Now if we were to run the code, our FPS is here at the bottom. And that's the very first part of the tutorial. We didn't do a lot, we just basically set the game state, created the player, created the load, the update and the draw functions, where the load sets the window title, it makes the mouse invisible, then we get to the update and it updates the player X and Y positions. Then on draw, it puts the FPS on the screen, and if the game state is running, it draws a circle with the player X and Y position and also the player radius. If the game state is not running, then it does the same as with running, but it divides the player size in two. So, first of all, this right here, this doesn't need to be here. You can actually remove that. It will run perfectly fine because by default Love will import it. But I'm still going to keep this here just to get all of those errors away and whatnot. So yeah, that's up to you before we continue, right? Okay, so in this tutorial we'll be creating the enemy. The enemy that's going to kind of run after us and whatnot. So first I would like to give our game another property. Difficulty. And difficulty is going to be set to 1. Now, the higher the difficulty, the more difficult the game should be. As simple as that. Because the speed of the enemies will be kind of dependent on the difficulty as well. And then we want to create a table called enemies. Now, this table isn't going to be used too much in this tutorial because we're only going to have one enemy. But once we get deeper into it, this table will be containing all our enemies. So all our enemies are going to go in here. We want to basically create our enemy object. Now we could do it in here, but this file is already going to be very big by the end of this tutorial. So we want to create a new file. So right here, we can right click, new file, and say enemy.lua. I'm going to give it a capital case E in its name to signify that this is an object. It's completely optional, it's just how I like to do things. If you have seen my tutorial on OOP, you will probably know there's multiple ways you can do OOP in Lua. And the first way is by using a table. The second way is by using a function and a table. And there are more ways, but I don't like covering the others because they're kind of difficult to understand, in my opinion. So in this case, I'm going to use functions and tables because I find those to be the most easiest to use. So first, we want to import love. So local love is equal to require love. Cool. And we don't need a semicolon. We're going to create a function and we're going to call it enemy. And this is going to be our object for enemy. Now, at the end of this function, we want to say return enemy. And this will basically export this enemy once we import it here. So this will be exported, this function right here. It's just so this massive function won't have to be found or used or whatnot in here. We don't have to see that massive function in here because it will be stored here. So let's start with very basics. We're going to return, and whatever is inside of this right here, this table, is going to be what's returned to us. So first we want to set the level to 1 by default. The radius, I'm going to make that equal to 20. Then the x is going to be equal to, and this is going to be enemy position for in case you didn't know. I'm going to make it, let's say, -10. And the y is going to be equal to -50. So basically, this is where the enemy's start position will be. We want it to be off the screen, and we're going to randomize where they actually come from later. But currently, we want it off the screen because it should kind of just pop into the screen as the level goes on. So more enemies will pop into the screen. Cool. So these are the first few things we'll use. Next up, we need to basically create something to draw the enemy and something to move the enemy. Let's first try and move the enemy, because that's probably going to be the most difficult part here, is just moving the enemy. And that's going to be a function inside of this table. So it's a function inside of the table. And it's going to take in 3 items. Self, yet again, in my OOP tutorial, because it's going to take in itself. We also want to get the player, player X and the player Y. You could pass in the entire player in here, but I feel like that would just be kind of a waste of memory on the end of the day because you're going to pass in an entire object where you can just pass in 2 values. So I do recommend passing in these 2 specifically, just the X and the Y. Cool. Now basically we want to make the enemy move to the player. That's all we want to do. Very simple. We just want the enemy to go towards the player. So it will just be basic if statements. So if player at index X, or at X position, minus self.x, and this self is referencing this X right here. So where the enemy currently is. So if this value is more than 0, then self.x is equal to self.x plus self.level. So what we are doing here is basically if the player x minus self.x, if that is more than 0, and we're minusing here because remember x starts basically at this point right here. Alright, so future Steve here, and you know, I realized this wasn't a very great explanation. So let me actually explain it better. Let me just move this to number 3. So
here we have basically our example. It's saying if the player at position, the X position of the player, minus the X position of the enemy. So let's quickly go here and just draw it out. Let's say the enemy is a red square. So this is the enemy. Or actually, let's make it a circle, otherwise things might get confusing. Okay, so the enemy is a red circle. And the player is a blue circle. Just draw a nice circle here. There we go. Now, here we're saying, if the player at position X, okay, so the X position of the player would be there at the center. That would be the X position from here all the way up until there. That's the X. Because remember, X goes from side to side. That's X. While Y goes up and down. So this would be Y. So just remember that. So this is the X, right? Now we go here, if the player X, and yeah, so if the player X minus self.x, and self.x would be the X of the enemy. So this right here, this would be the enemy X, that's self.x, so this is the enemy, self.x right there. Now if we go here, we see if it is more than 0. Okay, so let's put this in a mathematical perspective. So let's say this right here is 63. The X position of the player is at position 63. And the X position of the enemy is at position 10. Now we are saying player at position X, okay, so it's 63. Whoa, let me just 63, right? Minus self.x, okay, so it's minus 10, because remember self.x is the enemy. So it's 63 minus 10, right? And that will give us 53. So the position between this point and this point is 53. That's basically what's being said here. And then we're saying, if it is more than 0, and we know 53 is more than 0, then we're saying self.x. So this would be the player X, or the enemy X, not the player. The enemy X is self.x. So we're saying self.x is equal to itself. Okay, so self.x, which is 10. Let's make this red because we're talking about enemy. So it's 10 because we're saying self.x. Okay, so it's going to be itself, so that is self.x, plus its level, so plus 1. So we are saying self.x becomes itself plus 1. So now self.x will be 11, because it will now be one step closer to the enemy. Meaning this right here will minus with 1, because 63 minus 11, and remember we got 11 with that quick equation, so that would be 11. So 63 minus 11 is equal to 52. So that will basically close the gap between the enemy and the player. This might be a little bit confusing to work with, like a lot of the math might be in game development. But don't get discouraged, because the more you work with it, the more you'll understand it. So yeah, back to the video. Now we also want to do the other side of X. So let's say the enemy is to the right of the player. So else if, and then player minus self.x is less than 0. So basically, if the player X minus self.x, because remember X becomes more the more you move right. So if the enemy is more right than the player, then this will be a negative value. This will return something negative. So basically, let's say this right here, that's the enemy, and this right here, oh yeah, no, not yellow, we can't see that.
Okay, and this right there, that's the player. Now let's say on X, so X here would be equal to 2, and X here would be equal to 5. And remember, this is the enemy. That's why he's red. He is bad. He's the enemy. Bad. So let's just full screen this. So here we're saying if the player minus self.x is less than 0. So if the player, so 2 minus self.x, and remember this is the enemy, so minus 5 is less than 0, then do something. Now 2 minus 5 is negative 3. So this will return true. So if the enemy is to the right of the player, it will return true. And with the top one, if the enemy was to the left of the player, it would return true. If the enemy, it would be the same thing, just other way around. Now here we can just say self.x is equal to self.x minus self.level, because we want to decrease the x position of the enemy. If you're having trouble kind of wrapping your head around this, don't worry. The first time it can be a bit difficult. I had the same problem when I first thought of this, like, wow, my brain can't wrap around this math. But don't worry, it gets easier. And it's going to be the same thing, but for y. So if y, let me just change all of these to y. So if player y minus self.y is more than 0, then self.y becomes the same but plus. It's the same thing. Now it's just y. Because if I were to open up drawing, then basically remember y goes down. That's how y goes. So this is the player and this is the enemy. Now let's quickly go check here. So if the player y minus the enemy y is less than 0, so the enemy y, let's say, is equal to 10. Because remember, goes down. So this would be 0. And this would be something like 20 or something. And here, the y would be equal to, let's say, 5. Now, here we're checking if the player y minus self.y is less than 0. So if 5 minus 10 is less than 0, and those two minus will be negative 5. Right? And that is less than 0. Then we're saying, wrong window, self.y becomes itself minus the level. So it will decrease. So now we're saying, okay, move this upwards. So now the y will become 9 because we're moving it upwards. And this is going to run with every update. So it's going to move the enemy closer to the player with every update. So yeah, let's continue to the next part then. Now we want to be able to draw the enemy. So that was going to be another function called draw. It's going to be function taken self, doesn't have to take anything else. And here we first want to set the color. Love.graphics.set color. This is basically just going to set the color of the thing we're going to draw. Now I'm going to choose a very random number in order to figure this out. So I'm just going to say 1, 0.5, and 0.7. Just a random number that popped up into my head. Remember, you could have also gone like 255 divided by 255. And same here, you could have just gone, what's the half of 255? Anyways, the half of 255 divided by 255. So you could have done that as well, but I preferred not to in this case. And then we're going to draw a circle, but you can make the enemy a different shape than a circle. I just find it easier to do it as a circle. So love.graphics.circle, and we're going to fill this circle. We're going to put it at position self.x, self.y, and it's make the size of self.radius. So we're going to draw a circle at it's the x index, the y index, and then we're going to give it this size right there. And we set all of that up here. And then we can say love.graphics.set color. So we're going to reset the color back to white. because that's going to be our default background color. You don't have to set it here, but I prefer setting it here than having to set it here in this draw function over and over and over. It also just prevents a bunch of bugs that could possibly occur. Okay, so that's the most basic version. We'll later on throw in letting it jump in from random size, but I think for now that should be fine. So this is the enemy. Now here we have our enemy object, and now we can insert our very first enemy. So here in load, we want to insert our first enemy. Table.insert, and it's just a normal insert method. And I'm going to insert it into the enemies table right there. And we need to import enemy, now that I think about it. So local enemy. And you don't have to give it the same name. I just like using this name. And we're going to say enemy. And it should be capital E. That just means basically import enemy from this file right here. That's what we're saying right here. Cool. Now that we have that, we can go here and we can say at index 1, insert our first enemy. And it should not have a capital E because we gave it a lowercase e as a name. Or we should have. There we go. Lowercase e, not capital E. Okay, but you could give it a capital case E name. I just preferred going lowercase. Cool. Now that will insert our first enemy. Now here in update, before we can actually try and use this enemy, we need to basically for I, and yeah, let's just go like that. For I equals 1, and let's also remove all of that, until the number of enemies, and then do. So basically, for every enemy inside of this enemies table, currently we only have 1, but later we'll have more. We want to go enemies, or enemy, or yeah, enemies actually, and then add that index, so index I, colon move. Take note, I'm using a colon here and not a dot. And then here we can just pass in the player dot x and the player dot y. Why am I passing these in? Because here in move we're taking player x and player y. We do not have to pass in self because self gets passed in for us. Cool, so for every enemy, do this. You can also create an update function instead that will, instead of just moving it, it will do all of the updating for the enemy. That could also be something you can rather implement instead of move. But this game is so basic, I'm just going to have a move function and not an update. Cool, now we need to draw the enemy. Let's go here into if the game state is running, right? Then we can go and above the player, because we kind of want the player to overlap with the enemy, or you could do this below, it doesn't really matter that much. And actually I'm just going to copy this because it's going to be the same code, just a different command. So boom, and here I'm just going to say draw. So this will draw every enemy inside of the table. Okay, so let's try and run this and see what we get. Love dot. Let's see. And you know what? We're not getting anything. It's because currently we're in the menu state and everything just gets drawn if the state is not the menu. So yeah, let's go there and just go false. And in here we can just say running is true. There we go. Now it should work. As you can see there, the enemy comes to get us, but currently nothing happens, so the enemy just stops once it gets on top of us. But it should later on like stop the game if the enemy touches us. But you'll also notice the enemy always comes from the same side. And that's very boring, because we want the enemies to actually come from different sides to make the game more interesting. So to do that, we can just implement a little bit of math. And this math will basically make the enemy come from different sides. Now, here at the top, I'm going to declare 4 variables. Local dice, local x, and Y. And take notes, these have underscores. You don't have to give them names of underscores. I just find it much easier to work with them if they have that. And also local and an underscore radius. Cool. These two are not going to have any values associated with them at the moment. Radius will make 20 as a default, but you can later on then modify this radius to give you more interesting sizes. So let's say you want different size enemies. That could be kind of neat. Now this radius here, I'm going to paste it here. This X here, I'm going to paste it here because it's going to be modified. And this Y here, I'm going to paste it here. So these are all going to be modified except for radius. So these are all going to be modified, and these two will now be set here. And we're doing this because we want the self to work when we want these. Because this is not part of the table. It's part of the function, but it's not part of the table that's being returned to us. But it is part of the function. So this one won't be returned to us. We won't be able to access these values. But we will be able to access any values in here. It's something you have to wrap your head around because it can be a little confusing. Okay, and this dice will basically determine from which side will the enemy appear. From this side, from this side, from this side, or from this side. So I'm going to make this a math.random. And we're going to make it 1 and 4. And before we forget, in the main.lua file, not in the enemy, but in the main.lua file, we want to just math.random seed. And we want to just give it os.time. Now, what we are doing here is we're basically saying every second change the seed we're going to get. So whenever the user boots up the game, their random numbers will be more random. Because if we don't add this, then enemies will always start from the same place. And we don't want that. Because currently, as you might have seen in my random video, the random numbers don't really change. They kind of stay the same. Unless we seed them. So, unless we seed them. If you don't understand that yet, I do recommend you go watch my tutorial on it. I do have an entire crash course on it after all. Cool. Now we need to basically give the dice functionality. So we can say if dice is equal to 1, then underscore x is equal to math.random. So we're going to give it a random position on the x-axis. So anywhere random here. So there we go. Math.random. And then underscore radius, because we wanted to start at minimum at the radius. So the enemy will always be hidden, no matter where it is on the x-axis. And then love.graphics.getWidth. And this will just throw in the width. So it will give us basically a random number between the radius, so 20, and the width that's given to the window. And then we want to say y, or you can actually just do it underneath. Y is equal to minus, so negative, underscore radius times 4. So if the dice is 1, and this should be underscore y. So if the dice is 1, x can be anywhere on top of this right here, anywhere. But y specifically will be minus the radius. So remember, it's going to basically be here. So y0 is here. So y minus the radius would go up. So minus the radius will basically mean hide the entire ball, hide the entire enemy. And we times it by 4. So it's going to be basically being hidden 4 times itself. This will also give it a little bit of a time you have to wait once the new level starts before it actually starts jumping in. So it doesn't just go into the screen immediately. You'll kind of understand it once we actually use this. So now we can just say else, and I'm just going to copy this right here. Alright, a little disturbance. I can't remember where it was, but okay. Yeah, I believe it was just like this, and we go boom. Okay, now else if the dice is equal to 2, it's going to basically be the same thing. But I'm just going to copy these else ifs, because we're going to have kind of a lot of them. Except for the last one. The last one will just be else. And in this one we can make 3. And in the else would be if it's not 1, 2, or 3, then just give it this one by default. Okay. So with the second one, it's going to be a little bit different. It's going to basically be swapped. So X will contain this. And Y will contain this. And then here we can, instead of say get width, we can say get height. Now, why is this like this? Why did we swap it around here? Well, if the dice is 2, we're saying, okay, X should be here, but it should be minus its own width. So basically it should hide itself times 4. So it's going to go to the side here 4 times itself, its own width. And then with Y we're saying, okay, find any place from this part right here, right? And just anywhere towards the height. You don't necessarily have to specify this radius here. You could make this 0, because remember, it's just going to come in from a random side anyways. But basically, it's going to be able to come in from anywhere on this side right here. So if the dice is 2, anywhere here. If the dice is 1, anywhere here from the top. If the dice is 3, however, then we're going to do everything the same. But this one right here, this Y, we're going to say love.graphics.getHeight plus, and then we're going to say radius times 4. Whoa, radius times 4. And no minus. So why are we saying this here? Well, basically we're saying, okay, if the dice is 3, X can be anywhere from this right here. And then we're saying, okay, the Y should be the height plus itself times 4. So anywhere from below here. So now it's not anywhere from the top, but anywhere from the bottom, like from here. That's what we did here. We basically set the Y to the bottom of the screen. And then here it will be basically the same as with if dice were 2. So we can do like that. But now the difference is, and remember to remove this minus symbol right there. X here, we can just go and, well, no. We just go and do this. And we can say love.graphics.getWidth plus. And now what we're saying is, okay, it can come anywhere from this side right here. So now it can come, the enemy can come from anywhere inside of this window here. Not this window, but the game window itself. So it can either come from here, the top, which we did first, or it can come from the side, which we did second, or from the bottom, which we did third, or from this side right here, from the right side, which we did last. And now these X and Y values, as its default values that ball first gets, comes from here. And this will be different for every ball. That's the nice part, because every time we create a ball, it's going to execute all of this. And then it's going to return this to us. But this X and Y would have changed. And if you want, you can also change the radius. So yeah. Now if we were to run the game, it comes from down the part down here. Okay, let's run it again and see it happening again. Oh. Attempt to perform algorithm on get field a function value. So this is enemy 18. Let's see here. Ah, there we go. That should have those little bracket things there. Okay, let's see. And it starts from this side now. Okay, one more time just to make sure we have everything. It starts from the top. So that's the nice thing. Every time you start the game, it starts from a different angle, which is pretty neat. And I believe that's all we need to do for the enemy. Alright, so first we want to go to the main.lua file, this main one right here, and we want to make this true because today we're going to be working on the menu. So we want to be able to see the menu by going here to true. This shouldn't do much except for resizing your cursor, so make sure it does. Now we're going to create another table here called local buttons, and these buttons will basically contain all of the buttons for all of our different states. So menu underscore state will then become an empty table. Cool. So now that we have that, let's go here to the side and just create a new file. I'm going to call this button.lua. It's going to be a button class, and this button class will basically contain all of the things we'll need for buttons. So local love, which is optional, but I love doing this, require, and then we can just say love. Then you can create a function called button, and yeah, simple as that. Now we want quite a few things. We're not going to mess around with too many things just yet, but I can tell you from the bat, our button will probably have text on it, and we probably want to set the text when we create the button, so something like text. And we also need to be able to execute a function, so func, because when we click the button, it should be able to do something, and this func we pass in is what it should be able to do. This method isn't too great, I don't love it that much, but it does get the job done, and that's what we want at this moment. We also want to be able to pass an optional parameter into the function, so we can include func param. And then we want to include the width and then the height of the button. Okay, so next we can just say return, and it's going to return a table. This table is going to return will contain width, and that's going to be either the width passed in or 100 by default. And then we want a height, which will be the same thing, so like that. So either the height passed in or 100. Then we're going to create a function, and this function will be equal to the function passed in, to func passed in, or to a function that doesn't do much. It's just an anonymous function. It's not going to do anything really. It's just going to print this button has no function attached. As simple as that. If you wanted to, you can even make it shorter and make it one line like that. It's optional, you can make it more than one line. I kind of like it as one line because it just does a quick one-liner. And then the function parameter will be the function parameter passed in. If there's no function parameter passed in, it will be nil and no parameter will be passed in. And then the text will be equal to text or no text. Then the button's X position will be equal to 0. The button Y position will be equal to 0. And then the text on the button should be at position 0, and then the text Y of the button should be at position 0 as well. Okay, so this is a lot of things we're just setting by default. You don't have to worry too much about it. And then of course we want to return the button down here before I forget, because I'm going to forget if I did it now. Cool. Now we are going to do things like making the button clickable and whatnot, but first we want to be able to draw the button. That's the most important part right now, because we need to kind of get the button just on to see that it works. So let's create a draw function for the button, which will be a function, and this function takes in self, and then the button's X position, the button's Y position, and in the text X and the text Y position. Now, I might be putting it here, like the button X, Y, text X, and text Y might be able to be passed in from here. So these 4 attributes. But if you wanted to, you could pass them in here. The reason I'm doing this is if you ever later want to animate the button, so the button moves from one position to another position, then you can do it from here. You can, when you draw it, you can just move the button X and Y positions as you please, instead of having the X and Y positions kind of set as soon as you create the button. This is personal preference. I like doing this. You don't have to do this. You can put all of this. You can put it in here. There's no problem with that. I just want to do it here. And this also keeps this from kind of cluttering up and having 50,000 freaking things it needs to take in, because now it's being split into 2. Cool. Now here we want to say self.button X, and of course you could have made this a table as well, but we're already in a table, so having another table within a table is just, personal preference yet again. And that can be equal to button X, so this button X right here, or self.button X. So this button X here, or this button X here, one of these two. Self.button X is referring to this button X. Don't get too confused here. So just as I said, you could put the button X and Y up here as well, and it will be set here as well. Anyhow, and we can just copy that and do the same for Y. So self.button Y, like that. Then here we can basically set the text position. So if text X, so if the text does exist, the X position of the text, which is passed in here, then we can say self.text at position X is equal to text at position X plus self.button X. Else self.textX is equal to self.buttonX. Now you could have done this yet again in one line, where you basically check if this exists, and if it does exist, you do your things. You could have done it like this, but I find it to be a lot less confusing and just so much easier to also understand if you're reading it, if you do it like this, where if it's text X, do all of this, otherwise do this. Instead of using this OR way here, which could work, but I'd rather not, because that's going to be prone to bugs, because I'm not too good at reading that. And in here we can of course just go text Y, and in here we can say button at Y, like that. Now we're just saying the text on the button. So this is the text that exists on the button. If the X exists, so if this X position is being passed in for it, then make the original one here, make it equal to what is passed in plus the button X. We're saying the button X here because the button may be 30 pixels to the right. But the text isn't just going to be placed onto the button automatically. So we'll need to tell the text, add that X. So we're going to have our button X, and then we're going to need to add to it. That's this here. I'll show you how this works in a second once we actually draw this to the screen, just so you can kind of get an idea. Now take note, this bottom order I'm going to do here is very important. So love.graphics.setColor. And you can pass in your own color, the color you want for every single button. But in this game, I'm just going to keep all of the buttons the same color. 0.6, 0.6, 0.6. It's going to be a light-ish color. Then we want to draw the button. So love.graphics.rectangle. And if you're still a little bit touchy on this right here, don't worry, I am going to explain it. I just want to kind of give you something you can visualize when I explain it. And we can just say fill it, because we want to fill it so we don't see the background color of the game. And then self.buttonx, position at x, self.button_y, self.width, and it's self.height. So this is where the button is going to be drawn to and how it's going to be drawn. Okay, so that's for the button. We can do that. Now we need to do the text, because remember, the text isn't really part of the button. It's its own thing. So we need to do it here as well. So love.graphics.set color, and we're going to make it equal to black. Now you can make it a different color, but I feel like this color works perfectly with this lightish grayish color. Then we want to love.graphics.print, and we want to print self.text, self.text, and then self.text at position x, and then self.text at position y. Take note, I'm using self everywhere because we want to, on the end of the day, use this everywhere in our code. This will just make things so much easier. So whatever you do, do not change these values here or any values you set in here. Try and keep it as much as possible to these global-ish values we have here, because believe me, it's going to solve a lot of problems later. And then we just want to reset. This is optional, you can do it somewhere else, but I'm going to reset the color here to be white. So that's going to be my always fallback default color. It's going to be pure white. Okay, we have created the button, and the button can now be drawn. Now here we want to basically create the 3 buttons for our game. I'm going to create just one button for now. And here we have our menu state button. So we want to create it on here. So in the load, we are going to go here. So here with the onload, I'm going to create a button, or go to our buttons, say dot menu state, and then I'm going to add a play game button. Now this play game button is just going to be a button which we need to import. So let me go here and just import the button. And here we can just make that button. Cool. Now here we can make that equal to a button, which we just imported from this file we have here. Make sure to export the button by saying return button. And in here we can pass in our values. So first it wants text. So here we can just say play game, because that's what it does. It tells you to play the game. I'm going to pass in nil, because we do not have a function or a function parameter we want to pass in. Then I'm going to pass in, let's say 50 and 50. We're going to position it nicely later. So it's going to be the X and the Y position of the button. Now down here, where we draw the game, and here it says game.state running. We want to add an else if, because else if the game.state is not running, but instead it is of menu, and this should just be in square brackets, not circular brackets. So else if the game state is in menu state, we want to go to buttons dot menu state dot play game, and we want to say colon draw to call the draw function. And now in here we want to specify a bunch of things. So I wonder if it, yeah, there we go. So the button X position, we can go 10, the button Y position 20, and then we could just maybe say 10 and 20 like that, just as an example. Now it's not going to give us anything great. And was this really X and Y? What was this? This was, oh, the width and the height. So it's going to be 50 width, 50 height. And then here it's just going to draw it at position 10 and 20. And then the text is going to be at position 10 and 20 as well. But not the same 10 and 20 as this button, because we changed that. And I'll show you that in a second, because I know it's going to be confusing. And take note, this is still here, this if statement, because if the game state is not running, we just want the circle to be smaller. So the circle should be smaller in this menu state. And the circle should be smaller in this running state, or it should be larger in this running state. Anyhow, let's go here, and here we go. So we have a button, not really the best. It's looking kind of small there. So let's just make the button a bit bigger. So I'm going to go here to the above where it's 50-50. And I'm going to maybe make it a bit longer, so 120, and maybe a bit shorter or a bit less tall, so 40. Now that does look much better. Okay. And then here we have a play game, and you'll notice it looks kind of weird. Now if I were to show you something interesting here, so what do we have here? We have the button X and Y position, so let's make this text X and Y position 5 and 5, just so I can show you what's happening, because this is a kind of part that may have been confusing to a lot of you. As you can see here, it's 5 from this left side and 5 from the top. Now, if we go back to button here, and we don't do this, we just say, okay, just make them what is passed in. That's all you have to do. Just make them what we pass in. Or actually, no, let's actually change this up. So we go like that, and we uncomment these. There we go. So if we just did this, I want to show what would have happened. So if we just said self.text X and self.text Y is what we pass in, then you can't see it, because the text is now 5 pixels from here and 5 pixels from the top. Not from the button width and height, but from the top. So that breaks a lot of things. So if we change the text color then instead. So here it's 0, 0, 0, 0. We can just make it 1, 1, 1, 1 then. All these finger pop-ups. There we go. 1. Then you'll see it's right there. Now, we don't want that, right? We don't want that. That is why we have this right here. This self.buttonX. So even if we don't pass in anything, it's going to be at the same location our button starts at. So for example, if I were to comment all of this back in again, and I were to not pass in a text X or Y, which will run this then it would look like this. As you can see, it's right there at the button, but not at the game. So that is why we did that. We don't want this to start here at the game. We always wanted to start at the button X and Y positions. Cool. Now let's make this maybe like a 17 and a 10. That should look good for right now. Yeah, that looks perfectly fine. Later on, we'll change the font a little bit to be a bit bigger and just match the button better. But for now, I think that's fine. So yeah, there's our first button, play game. Let's create 2 more buttons. And I'm going to just go here. Now this second button is optional, because I'm not going to code it. It's going to be your homework at some point. So settings. So this is going to be the settings button. And then we want an exit game button. And in this button, we'll say settings. And it's going to have the same width and height. And in this button right here will be exit game. Or just even exit if you want to. And in the same width and height. And because all of them are the same width and height, you could always make this the default width and height. Like here where we do this, you can make it the default here. That would actually be a good idea. Now we can code the exit button right now. We can give it its function. So love.event.quit. Because this will quit love. So once the button is clicked, it will run this code. Or we haven't really implemented that, but that's what it should do. Take note, all of these are from the menu state because they will all be displayed once the menu state is true. Okay, now we can go down here again and we can draw the game. So let's go like this. And let's draw settings. And let's draw exit game. And let's see, how do they look? What do we see? Okay, we just see exit game because that's what's been drawn last. So we can just make them all go down a bit. We can leave the rest to be exactly the same. So we can say 70, and here we can maybe do like 120. And that looks fine to me, at least. So now we have a play game, a setting, and an exit game. They don't do anything if you click on them, but now we have that. Now we want to go back to the button because we need to make some function that will allow us to press the button, to click the button. So we're just going to check if it's been pressed, and we'll do the press doing on the main, in the main file. So here we can just do something such as check pressed, right? And in this will be a function, and here we can just put a comma. Cool. Now this will take in a self, a mouse, X position, so where the mouse currently is at the X position, the mouse Y position, so where the mouse is currently at the Y position, and in the cursor radius. So if we ever change the cursor size, we don't have to worry about changing it here as well. So cursor radius. Cool. Now here we can just create a basic if statement. So if mouse, of the X position of the mouse plus the cursor radius is more or equal to self.button X. So let me actually draw that because I think this will become a little bit more difficult to understand. So let me just go like this. So we are saying, let me just make this a good easily seeable color on white. So this is our cursor, right? And this is our button. I'm going to say B for button. Now, if I go here, you'll see the mouse X position. Okay, so the mouse X position. And remember, this is our mouse. That right there is our mouse. But remember, our mouse, if I can just make this red maybe, our mouse is here in the center. That is actually where our mouse is. That's where the point of our cursor is. You might have remembered from the first video, where when we drew this, you would have noticed the mouse cursor thing. It's like that. So that's our mouse. Right there. Now, we go back here. There we go. We say if the mouse X, okay, so this is X, remember? So that's X, and this is Y. So, because remember, this can make a Y-ish shape. That's why this is Y. This is X. So if the mouse X position, let's go like that. So this is the mouse X, right? So, boom. The mouse X position, right there. Let's make that 32, for example. Right? Plus the cursor radius. So this part right here, this is the cursor radius. Because remember, a circle, whoa, not a good circle there. A circle has a radius. That right there, that's the radius of a circle. So take note, that term is very important. That's the radius. It's only half of the circle. So this right there. So this X plus the radius, and let's say this whole circle is 20, right? So the radius would then be 10. Because if the whole circle from here to here, if that whole circle is 20, and the radius is half of the circle, then it would be 10. That would be the radius. So 32 plus 10, that's 42. So we're saying if 42 is more or equal to the button X position. So let's say this button X position, which is obviously further than that circle. So that would be this button X position, which would be like this. This is the button X position. I should actually choose a different color at this point. Let's go maybe something like a bluish color. I hope everyone can see that. Yeah, nope, let's go like that. Okay, so this is the button X. The button X we can say is 62. This would then be false, because here we're saying if it's more or equal to, very important. It's not more or equal to 62. It's 42. It's less than 62. So if we move our cursor, so the cursor is, let's say, like this. So you'll notice the end of the cursor is inside of the button. This would then, remember that's the radius, right? And this is 32. And let's say, I don't know, this right here, that part right there. So from this point right here to this part right here is, let's say, 45. Because remember, there's not like a lot there. So that's just 45. So 45. Then we can just add the radius to it to get back to the middle. That would be 10, so we can make that 55. Right? Now we can add the radius again, because we're at the center. Or we could have just added this full 20. That would have worked well. But if we add the radius again, we'll get 65. So remember, this right here, that's 45. This whole length here, that's 45. Because that's just what number we made up at this point. And then we add 20 to get from this point of the circle to this point. Or 2 10s to get 2 radiuses. Because 2 radiuses makes one of the circle. Because a radius is half of the circle. Very important to know. And then we get 65. 65 is more than 62. Thus, we are pressing the button. We are now pressing the button. That is what all of this math does. If most of this math went over your head, don't worry too much about it. You can kind of figure it out on your own as you play with this. But basically, if a part of the circle, no matter how big the part, but if a part of this circle we have goes over the button, this right here, that's the button, then we should say it's clicked. So that this is just for the X, right? Simple as that. Now we also need to do it the other way around. So if we go back here, and let's actually, can we create a new, no, I don't know how to create a new one. Control N doesn't work. Okay, that's fine. Let's say we have this is our circle, and this is our button. So this is button. Now we need to do the same thing, but if the circle does this. So we need to do the same thing, because we need to take note. We should not press this button. We should not be able to press it if our circle is here and the button is here. Or if our button is here and the circle is here. We should only press the button when the circle is basically on the button. A part of the circle should be on the button. But if a part of the circle is not on the button, no matter if it's to the left or to the right, we should not click that button. Only if a part of that circle is on the button should we click the button. And oh, okay, it did make more. Okay, good to know. Good to know. So now we need to do the same, but the other way around. So I'm going to just put that inside of brackets to make it easier to read. And I'm going to say and. Start another pair of brackets and just paste that in here. Now we want to minus the cursor radius here. And we want to say, instead of more than or equal to, we can say less than or equal to. And I recommend, if you kind of struggle viewing what we're doing right now, if you're kind of struggling seeing what's happening, draw it out. Drawing out math is probably the best thing you can do, because that's what we just did. And if that helped you to understand at least the first part, then that means if you draw it out for yourself, then you will be able to understand the second part as well. And in here we can just add width. So plus width. Self.width, that is. Now this self.width, remember, refers to the width of the button. So let me actually draw this again. So draw. So here we're saying, if the mouse X, so here's the mouse, let's do this, mouse X, right there. That's where the mouse X is. So let's say X is equal to 32, right? If that is less than or equal to this button X, right? So this button X right here, it starts there. That's where the button X starts, right there. Plus the button width. So it's going to be plus the button width. So this is where it's going to be. This dot right there, that side, that corner. If it is less than that. And we're minusing the cursor radius because we want this point. So if this point is less than this side right here, then this X right there, if it's less, then we want to do something. So let's make this blue. So if this part right here is past this part, so if it's more than this X location, because remember, X is just a position, and this red part right here is below this red part right here, then we want to call the button. This can be very confusing, and I myself got confused here, but this math is very important to understand because in all future games, this is how you can code a button. Anyhow, so I hope you understood this part. If you don't, you can still follow along without any problem, because believe me, I'm also trash when it comes to math. Cool, now we need to do the exact same thing, but we want to do it for Y. So here we can just change mouse X to mouse Y, right? And then we can do the same here. Button X, but button Y. And instead of width, we want to say height. We still keep the cursor radius, because remember, it's just a circle. Meaning, if we go from the center of that circle, and we add the circle radius, whether it be left, right, or up or down, then we'll get the edge of that circle location on X or Y axis, depending on which we choose. So it should still have the cursor radius. So if it's more or equal to the self.button Y and mouse Y minus cursor radius is less than or equal to self.button Y plus self.x or self.height, then, and take note, we're using height with Y and width with X, because width is left to right, height is top to bottom, just like how Y is top to bottom and X is left to right. That's why we use those two respectively. Okay, now we know the button is inside, or the cursor is inside of the button. We know that for a fact now. So we can just start executing stuff. So self.funcParam. So if a function parameter exists, if one was passed in, right, then we want to call self.func, and we'll do pass in self.func parameter, like that. Else, we want to do the same thing, but this time we just don't want to pass in a parameter. So if a parameter was not passed in, we don't care about it. And just like that, we have implemented a press operation for our button. Alright. Whew. That was quite a long one to do. We are almost at the end though, so don't get discouraged just yet. Cool. Now I'm going to create a mouse pressed function. So whenever the mouse is pressed, now you can do that within draw, within update, within load. I'm going to create my own entire function for it, which is possible with Love2D. I didn't do this in the tutorial because I kind of wanted to keep it for this tutorial. So if you don't notice this from the tutorials I had, don't worry, I did skip it for a reason. So we can just say function love.mouse pressed, and I find this to be a lot more powerful than the one we had in the tutorial. And you can just say x, y, button is touch presses. So all of these gets passed in for us. We get the X position of our cursor, the Y position of the cursor, where the right button was clicked, the left mouse button was clicked, or the middle mouse button was clicked. I think there's probably support for other mouse buttons, like the ones you get on the side of some mouses and stuff like that. I just don't know how to work with them. And then we have is touch. So basically, is it a touch screen? So touchscreen mobile support. So is touch, and then presses, so how many presses, I believe. So basically if they touched with their finger, and here's how many times they touched, or how many times they clicked or whatnot. We are not going to implement touchscreen support in this game, because I think that's, I don't know, I just think that's something you could probably do if you wanted to, but it's quite a lot of debugging, especially if you don't have a touchscreen yourself. Anyhow, we can then just say if not game.state is running, because remember, we don't really want the mouse to be able to click anything if the game state is running. The mouse buttons shouldn't do anything while the game is running. Then, so if the game is not running, then you're allowed to do anything in here. We can say if button is equal to 1, meaning if we pressed the left mouse button, so not the button that brings up this one, but the other button, the one if I click like this. If we click this button, then do something. So if game.state, so if it's the menu state, we want to specifically use the menu buttons. Then you go for index, and we don't need a value, and we can just say buttons.menu state. So we're going to loop for all of the buttons in the menu state. That's why we created it here, because we're going to loop for all of these buttons inside here to check if they have been pressed. That's why it's in the menu state, so only if it's the menu state. This is also to save a little bit of performance. We're going to say buttons.menu state dot, or not dot, we can just say position index. So that should be a dot. So buttons.menu state at this index. So let's say the play game button, for example. And then we want to just say check pressed for that button. And we want to pass in the X, the Y. And the X and Y is basically the cursor X and Y that we're passing in. And in the player dot radius. And the player radius is coming from here. There we go. The player radius, which in this case is actually 20. So yeah, that's the radius. It's half of the whole circle. Anyhow, so we pass that in. So it's going to check if any of those buttons were pressed. So if I were to now run this, and let's try X again, because that's currently the only button that has anything implemented. And we actually get an error, but it worked. So button.lua at 17. Okay, so button lua at 17. Attempt to perform algorithmic on field height, a null value. So let's see here. Height, self.height, which is a null value. Oh, probably just spelled it incorrectly. There we go. Actually, I think height might be spelled incorrectly. I don't know. I can't grammar for the life of me. Now let's try it again. And it worked. Our game exited without any problem. Cool. Now let's quickly work on the start new game function, and then we're done. then we can turn it off for today. So I like to do that underneath. I don't know. Actually, I think I'll do it above load. And maybe I'll even put this mouse pressed right here. I'll put it above load as well. Why not? And we can just do that. Boom. Okay. Now here I'm going to create a local function, and I'm going to say start new game, right? And then it doesn't take in anything. We can just say start new game. Then game.state at menu. Whoa, whoops, my bad. Yeah, at menu, right? Then becomes false. So we're setting the menu state equal to false. And currently, because we only have the menu and the running state, we're not going to worry too much about the other states. But now we can set this running state equal to true, because we're starting a new game, so we should start running the game. And in here, we can also just create our first enemy as well. So this part right here, we can completely remove it and just move it up. So now here, we just boom, like that. Then whenever start new game is pressed, we're going to insert a new enemy into our game, and we're going to set the menu state to false and then the running state to true. Okay, now let's actually just implement that here. So where it says nil, we can say start new game without the parentheses. Take notice, without the parentheses, because otherwise it's just going to execute before it gets passed in. And yeah, then one last thing. This is going to become more helpful later in the game, but we can just say if game dot state is running. So if the game state is running, then we want to do this. This is so the enemies don't try and keep chasing the player if the player is like in the menu or the game is paused or anything like that. Because believe me, it's going to be very funny, but the player isn't going to like that. That they can still lose while in the menu or something like that. Anyhow, so we just say they're only allowed to move if the player or if the game state is running. Cool, now let's try and play game. As you can see, not only does our player grow, but the enemies now start following us as well. That's pretty neat. So we did quite a lot in this tutorial. Well done if you're still following along. So basically, we created our first buttons. We implemented touch for those buttons. We implemented the drawing the buttons. And then we implemented the actual functions of the buttons. And that's that. So let's actually start with the enemy. Let's actually try and improve the enemy. So first off, I would like us to actually now receive a level. Now level is basically going to allow us to say what level every enemy should be. Because we can have 10 enemies in the game, like just coming at you. But the problem is, without the right leveling method, those enemies will just be kind of the same thing. Whether it be difficult or anything like that. So what we can do is we can go here where it says level, and instead of saying 1, we just make level equal to level. And just in case we didn't pass in a level, but usually you would be passing in a level. But just in case we were not, we can just say, or let's say 1. And you could also, if you want to make this underscore level instead of level to make it a bit easier to understand. Although I think this is perfectly fine. You can even rename this to be LBL instead. Alright, so that's all we're going to do here for now. We will be getting back to this later, but right now I think it's perfectly fine. You probably want to know how we're going to kind of get the enemies and stuff to come in. So I'm going to show you an example of what we will basically be doing. So here I have basically what we're going to be doing. So when we say play game, we will have a little scoreboard here that is going to count. And then once this scoreboard gets to a specific amount, like 15, it's going to spawn another enemy with a higher level. The higher the level, the faster the enemy will be. A good thing you might want to do is you might want to make every enemy a different color, maybe randomly generated or something like that. And then once the enemy touches you, the game ends. We'll later on implement an end screen or a game over screen and whatnot. But that's the basics of what we're going to implement. So we need to implement some sort of point system. Alright, so here inside of game, we can actually implement it here. So the amount of points we have, we can make
equal to 0 at start. You could also put this inside of the player here. So then the amount of points the player has. But you could also make the amount of points there currently is in the game. So whichever floats your boat best. And in here we could say levels. And this will basically be whenever an enemy spawns. You can either have set levels like I am doing now, or you can have randomly generated levels, or levels at every specific interval, something like that. But I'm just going to have 4 levels, 5 if you include the very first level, and these levels will basically just be 15, 30, 60, and 120. So if you have these points, so 15, 30, 60, and 120, like that. So if the player has 15 points, then a new enemy will spawn. If they have 30 points, then a third enemy will spawn, because you have the first enemy, which is from 0 to 14. Then you have a second enemy from 15 to 29, a third enemy from 30 to 59, and then a fourth enemy from 60 to 119, and then the last enemy at level 120 and above. So let's implement the points. So here with new game, we can just say game.points is equal to 0. So this is basically whenever we start a new game, we're going to set the points to 0. And now with these enemies here, we actually want to do something but different. We want to go enemies. So we want to create an entirely new enemies table. So we're going to clear the previous enemies table. And we can just say enemy and then at level 1, like that. That means we can remove that line there because we have our enemy here. This will be the very first enemy at level 1. You can do it like this, or you can have it split up into multiple lines. So right here, where we do the love.update, inside of the game state, or inside of the if game state is running, this part right here, we want to just say game.points is equal to game.points plus dt. So this will basically increase the points constantly, but with dt, so 0.016 or 0.032, however, so basically about every second you'll get 1 point. Now when we go down to draw, we can find a way to actually display this to the user. So here in if game state is running, we can actually put it just above enemies so the enemies can move over it. But you can put it below enemies as well. We can say love.graphics.printf, and this will print text to the screen. We can say math.floor game.points, and this will display the game points but to the lowest value. So if we have 3.14, it will display 3. If we have 3.55, it will display 3. If we have 29.99, it will display 29. So it's basically like math.round, but just always downwards and never upwards. We can then specify a font, because with Love Graphics Print, you might notice we need to specify a font. So let's just say let's just copy this. Now we want it to be bigger than something like the FPS, because it has to attract more attention than the FPS. So we can make this about 24 instead of 16. Then here we can basically put our location, so 0, 10, and then we can tell it how long to span. So love.graphics.getWidth, and then we can also just specify center. So all of this does a lot, but basically you can think of it as displaying the text at the center of the screen. And I'll show you how this looks in a second. So let's actually try and run this and see if it works. So love. Alright, we say play game, and here it does. So it's here at the center of the screen, near the top. And yeah, it just counts about every second. I believe this 0 here is the X. So if we were to make this something like 90 and we run it, then you'll notice it's a bit more to the right. So the 0 is basically the X and this 10 is basically the Y. Cool. And then this here just specifies you want it to be basically aligned to the center. Nice. Now, before we get to the enemy, I would like to implement a better way to change the game state, because currently the way we change the game state, we have to constantly go around and we have to change a bunch of things manually, which isn't what we want. We want to make it as simple as possible, so in the future when we return, we never forget about something we might have to change if we change this value here, or if we add this here. Alright? So let's say local, and we create a function, we can call it change game state. I can take in state, then here we can say game.state menu. So the game state is menu, or we actually just make it state is equal to menu. So we basically say make game state menu, so true or false, if the state passed in is equal to menu. So if we pass in menu here, it's going to make this value here that. And we can do the same for all 4 of our current states. So paused, and here we can say running, and in here we can say, and then we say ended. So we never have to worry about changing another game state, because here it will automatically make things true and false as we want it. So for example, here where we do this, instead of having to set 2, 3, 4, 5 states here, we just call change game state like this, and we want to set it to running like that. And that will just make our life so much easier. Since now whenever we change the game state, we don't have to everywhere we want to change it. We don't have to constantly basically be doing this, because now we have a function. Let's make sure this works. So if I press play game, it should start the running state. And it does. Alright. So next up we should maybe work on getting if the enemy has touched the player. If the enemy has touched the player, the game should end because the player has lost, because that's the point of the game. So what we can do is we can go here to enemy.lua and we can implement a new function, check touched. Now this check touched will contain a function, and this function will take in self, player X, player Y, so the player X and Y position, and then also the cursor radius, like that. And I did explain a lot of this in the previous tutorials, so I do recommend you go watch that if you have not, where I do explain a lot of collision detection math there as well. So now we just basically need to detect if the enemy is anywhere near the player. There's going to be some interesting math here, so just bear with me for a second. Math.square root. So SQRT for square root. And I'm going to create 2 brackets here so I don't get confused with mathematical operations, and so Lua knows what to do first. Self.x, so basically the enemy current X position, minus player underscore X, so the player current X position, to the power of 2. And I'll explain this in a second. Then you can say plus, and then another pair of brackets, self.y minus player underscore y. And we just say times, or to the power of 2. less or equal to cursor radius times 2. So basically this math here will check if the player is inside of the enemy. So it's basically like the previous one, just kind of in one line to make it easier for us. You could split this up into multiple lines again, very similar to what we did here inside of the button check pressed. You could make it very similar to this. Not exactly like this because, one is a square, the other is a circle. But hint here, both of them are circles. But this will basically, in a sense of argument drawing up here, it will do this. So this is the enemy. This is the player. Whoa. Now in this scenario, so this is the game scenario, it would be false. Now our math will basically check this. This is the enemy. This is the player. Now that will return true. So it will just basically check if the enemy or the player is touching each other. Because if so, then they are colliding, meaning the player has lost. So yeah. If you want to know more about this math, I do recommend you do go maybe refresh up on some mathematical things you can do with circles, because this is one of the things that works with that. Alright, so once you have that, you have your collision detection. Now with your collision detection, we can finally do some coding to actually see it do something. So let's go here to the running state right here. So inside of this for loop, we're going to increase a few things here. So increase the amount of lines. So right here, we can say if not enemies at index I, and we're getting this right here. If not enemies at index I, check touched. And this check touched will just basically execute this math right here to check if the player is inside of the enemy. Then once you have this, you can just say player dot x, player dot y, player dot radius. Because this check touched needs three things: player x, player y, and then the cursor radius, which are all provided here. This will check if it is touched. So while it is not touched, as you can see there, because that has a not. So this will check if it's not true. So if this does not call true, if it's not being touched, then. And in here, all of our things will happen. But let's first code the else. Because this is a quick one. It's just change game state to menu. Later on, this will change the game state to ended and whatnot, but we don't really have anything for those states. So currently, it will just change the state back to menu. And see, this is why this change state is so useful, because now we just call this and it will do all of the other background stuff for us. Now this enemies.move here, or this enemy move, we can move it there. So the enemy can move. So we can now say for I is equal to 1 in game.levels do. So we're saying for I becomes 1 in game.levels. You could call this something else even if you wanted to, because we have an I here. So you might want to call this something like J or K or some other value. And game.levels, and game.levels is right up here. So it's 15, 30, 60, 20. So we're saying for I equals 1 through that. We can go if math.floor, yet again, this is to make sure we round down. Game.point, and this is the points we have scored up until this point, if you can remember. And we can say if that is equal to game.levels at index I, then we want to say table.insert
and enemies, 1, and then enemy, and game.difficulty times I plus 1. So what are we doing here? We're basically saying insert into the enemies table at position 1 an enemy that has the game.difficulty. So the game difficulty is basically being set up here, so it's 1. So in this case it's just going to be 1, but if you want to increase the game difficulty then you can, times, in this case it's going to be 1 plus 1, which is 2. But if this I increases, this would be 2 plus 1, which is 3. And then this will basically increase the enemy difficulty or the enemy level as things go on. We did implement the leveling thing with the enemy in the previous vid. I think it's actually in the 2 videos ago, not the previous video. So let's see here. Let's just search level. Yeah, there we go. So self.level in the move. So we did implement working with level, so we didn't have to mess with that now because we did it before. And then this is both to avoid bugs and to kind of tell the player, you have done this. We give the player 1 bonus point. So game.points is equal to game.points plus 1. So we gave them 1 bonus point as well as trying to avoid a bug. Because otherwise this for loop is going to run multiple times. Because DT is going to take a while before it goes 1 full point, because it's like 0.016 or 0.032. So yeah, we have to be careful with that. So we give it 1 extra point so it can also break out of the loop. There are also other ways to deal with it, but this is the easiest way I find to go around it. Now once you have that, you can just save your game or your code and let's see if it works. Play game. Okay, so here is the first enemy. We wait until we get to 15 to see for the second enemy. And here we go. So now there are 2 enemies. If we are willing to wait to 30, we should see a third enemy. That is even faster. Yeah, as you can see there. And then once one of them touches us, we just go back to our main menu. And yeah, that is it for this tutorial. We just implemented a basic point system, and we implemented the basics of adding more enemies. Let's start with fixing something up first. Currently, we don't use fonts very nicely. Because if we want a set font that we might want to use over a large amount of spaces, this isn't going to work that well. Because we have to basically come back here, copy and paste or remember this number. That is why I think it would be best to create another table. And this table, we can say it's called local fonts. Now local fonts will just contain a few fonts for us. So medium, and this would be of course a medium-sized font. I'm not going to have small or extra small fonts. I'm just going to go medium, large and massive, because these are the different sizes that I'm going to use. Nothing is going to be really small. And I'm saying medium because the size of medium is going to be 16. And if you're a web developer, you know the default font size is basically 16 pixels. Anyhow, so we can say font is equal to, and I'm going to copy this font because it's basically just going to be this right here. So I'm going to paste that there. And then I'm going to say size is equal to 16. We won't really use this part too much, but it's more for future reference because sometimes you want to access the size of the font and not just the font. So it would be good to include the size. So if you ever want to know like the font size, like let's say you're in settings and you want to increase or decrease the font size, then the player can maybe choose between large, medium and small.
and you can tell them the font size is 16 and then it's 24 and then it's 60 or what not. Cool. So that's just for future reference. Mostly it's not per se you're going to use, or not two sets you're going to use it. Now I'm going to have two more fonts here, one called large and then one called massive. So large will be, instead of 16, 24. And massive would be, instead of 16, it will be 60. Like that. So now we have a fonts table. So first let's go down here to where we draw, because this is mostly where we're going to use the fonts. Now we want to set the font to its default whenever we draw. This is mostly just because if we do set a font somewhere, then that font won't just stay there the whole time. And you'll notice when we get to the end game state that this right here will become quite important. So love.graphics.set font. So we're going to set a default font for every iteration, and it's going to be fonts.medium.font. So we're basically saying add from fonts medium, and then from medium we add font, and font is just this right here. That's basically the medium font. In fact, we can copy this and we can paste it right here. Boom. Now it's fonts medium font. So whenever we draw this will be the medium size. This right here, this would be the same, but instead of medium, it would be large. So this will be a large font. Alright, and that's currently all the fonts we really have. If we run the game, we should not be seeing any difference really. So as you can see, fonts still look the same. If we say play game, that's still the same size and that's still the same size. Cool. Now I think it's time we start working on the end screen, the game over screen. So we'll need to create the buttons for this screen. So here with this state right here, this buttons, we can go here where it says menu state and we can make it ended. You can make this game over or whatever you want to call it. I'm going to call it ended state. So now we can have game over buttons. Now we can go to love.load right here and we can copy and paste this like that, and instead of menu state we can turn that into ended state. Now the first one is replay, so if you want to replay the game, so replay game. The second one is the menu button if you want to go to the menu, so we can say menu. And the third is exit game. Exit game will contain all of the normal values, so love, event, quit, and just exit game. This will contain menu, and here we want to pass in change game state, and the state we want to change it to is menu. Now take note, change game state was declared right here, where it just changes the state to whatever is passed in. And then of course we want our replay, so right here, replay for replay game. Yeah, we can make it full replay game. And in here we can just say start new game. Now currently we didn't actually ever see the ended state, so we'll need to go here to update and we'll need to change this to ended. So from menu to ended. This will, instead of making it go back to the menu state where we see the menu, it will make it go back to the game ended state or the game over state, and we can see the game over screen. Then we can go down and we can copy this else if. We'll see, and like that. Now this else if will be, instead of menu, it will contain ended. Cool. Now I'm going to go love, or let's just copy this here, love.graphics.set font, because for the indented state we want to set the font to be something a bit bigger. So font.large, and this will make the font a bit bigger. This will allow us to basically everywhere within the game, while it's indented state, just increase everything with size. Then here we can go back up here and we just copy these 3 names here, and we can go back down and we can paste them here, and in here we can just make menu ended. So let's see what we can see. So when we run the game, what do we see? Okay, so we see this. It doesn't look great. We can definitely make it a bit better. For example, instead of having it here at the side, I think it would be better if we had it here in the center. And we of course have to resize it a bit, just make everything look a bit better. So first, let's try to center everything, because I think that would look best. So here, everywhere where I say love.graph, or where I say 10, we can say love.graphics.getWidth, and we can divide it by 2.25. Now this is a very specific value here. This value was actually calculated while trying to find the perfect way to center our buttons. Because currently we can set the button X and the button Y. And this process right here allows us to make the button more centered. If you have a different aspect ratio for your game, so if I were to just quickly run this, if your game wasn't this aspect ratio, which I think is 4:3, or it just actually looks like a square, it might be 1:1, but if it wasn't the same aspect ratio, the same size, then you will have to change these values here. Or you might have to. It's not maybe you won't have to. Maybe you're lucky. Anyhow, and in here where we say 20, 70, and 120, we can say love.graphics.getHeight, because this will be the Y position. We can then just divide that by 1.8, but that's only for the first one. For the second one, we will want to make that 1.53, because remember, unlike with X here, where basically all of them will just move here, all of them will now move top to bottom. So if you make this the same, they will all be at the same Y position. And if they're all on the same Y position, they're going to be stacked on top of each other. You can play with this a little bit if you want to see what the difference would be if you didn't add that and stuff like that. And in here we can say 1.33. Cool. Then for the last two ones, which would be the text positions, we can specify 10, 10. And then here we can just keep that 1710, and in here we can change that to 2210. This was quite a lot of changes, so let's first see what we have, because currently we did a lot of things. So let's see, how does our things look? Alright, so that's already relatively close to the center. The reason why it's further down to the bottom than what it is from the side is because we want to put our score here in the complete center. So this will be below the score. That is why it does this. And the buttons work, so if we go to menu, or they don't because we haven't implemented clicking yet, so never mind that. Alright, so let's do the points. Let's quickly draw that before we continue to the buttons. So love.graphics.printf, and we can say math.floor game.points, so we're going to put the game points for everyone to see. We can say fonts.massive.font because we want it to be massive. We're going to set this to 0. Then love.graphics.getHeight. And we want to divide that by 2 because it's going to be kind of halfway. And then we also want to minus the font size because remember, it's basically going to look like this. So if I can open up my drawing application, it's going to look like this. So this is our font, right? But you have to remember, so let's say that is the 0 character. But you have to remember, fonts are actually inside of squares, just like images. So this is actually how the font looks, somewhat similar to this. So when we do that, we're basically saying this. Now we have to minus the font size, specifically because the font still goes down. So if we minus the font size, it will go from here, but up until, let's say, this point here. Because that would be the half of this font if we were to circle it like that or something. This might be a little bit confusing to understand, so let me actually show you. So instead of minusing it, we'll keep it like this for now. And then we can say love.graphics.getWidth to say where it should bend. And then we can just specify it should be in the center. Alright, once we have that, we can do this. Play game. And as you can see, the 1 is right there. And if we want this to be a bit more up, we'll have to minus the font size. So minus fonts.massive.size. Not the font, but the size this time, because we want to minus it by 60. Now if we were to run this, boom, our 2 is nice above the buttons. Now what I would like to do is I would like to go up here a bit to where we were here. And I'd like to change all of these 120s to 100 instead. And in this 40s to 50s. And let me show you why, because now it will look actually a bit better. So if we could just go like this, as you can see, it just looks a bit better. And I don't think this end game looks that great, and I don't really want the buttons to be too long, and I want them to all be the same length. So instead of exit game, let's rather say quit, because quit won't be that long. So quit. And actually, while we're at it, let's make this, instead of a replay game, we make it replay instead. And this will make everything nice and short, so when we get to the game over screen, everything fits into the buttons nicely. Alright. And that is actually just perfect. Next up, we need to make the buttons able to be pressed, because currently the buttons have nothing to check if they're being pressed. So here where we say if the game state is menu, we can say else if. And then we can do the same thing here where we say menu, and instead of menu we say ended. And in here we can just specify this. But this time, instead of saying menu state, we can say ended state. And everything else can stay the same. You could even maybe create a function that will replace this for you, so you don't have to do this every time. Anyhow, if we were to now run the game, our buttons will work. So if I were to end the game here, say replay, we can replay the game. If I say menu, we go back to the menu. And then if I were to say quit, we exit the game. And that is basically all for this tutorial. You will notice that the game is not quite finished yet. There's quite a lot of things you can still do here. And I believe the best way to learn is to do it yourself. I am going to bring out another course which will cover some of the topics I'm going to give as homework. So if you can't figure it out at all, once you watch that tutorial, you should be able to get a sense of how to do it. So let's first start with what we need. First of all, you'll notice if I were to just move this to the side a little bit, we have a paused state here, but we did not implement that paused state. Implementing a paused state is incredibly simple, and I will be doing that in the next tutorial as well. But currently, we don't have that paused state. I want you to try and implement that paused state. It's very, very simple, and it's probably easier than you think it is. Next up is the settings page. We have a settings button, but currently all it does is say this button has no function attached. This is a bit more complex, and there's a lot of ways you can implement the settings button. I want you to try and do it first. In the next tutorial, it's going to be your homework again, but I'm going to give you a kind of an example, a sort of, hey, you can do this. So you can try and do it here, and I recommend you do because it's quite a challenge. And if you do it right, then you have a perfect settings menu. Otherwise, you can wait till the next tutorial where I will give you a little bit of a push towards the right direction. I'm not going to implement an entire settings page, but I will show you kind of a way to get started with it. And next up is make the enemies more different. Currently, the enemies are quite boring. They're all circles, they're all pink, and that's it. There's nothing special about any of these enemies. In the next course, I will show you a basic way of how to make your enemies more different. So stay tuned for that if you do want to get the answers to this as well. But changing these enemies up to be a bit more different, like maybe making them, instead of circles, make them squares. That could be a great idea. Maybe start a scoreboard as well. So let's say you can have a high score, and then you can compete to beat your current high score. I'm going to show you how to do this in the next course as well. But I would like you to try and implement this here as well, because it can be quite difficult. Ooh, that's a fast one. It can be quite difficult to do. So I would recommend you try and do it on your own first. But that's it. That is the end of this tutorial. If you enjoyed this tutorial and would like to see the next course, please leave a thumbs up, maybe even subscribe, and I will see you all again in the next Love2D tutorial.